Hey everybody, this is Larry. This is day 19 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's prompt. 211, design, add, and search words data structure. I cannot read today, so yeah. Hope everyone's having a great weekend. The weekly contest is in an hour or so. So if you're doing it, good luck to ya. Did okay on the bi-weekly in case you're curious. That Q1 was killer, right? Let me know if you did it, the bi-weekly, and let me know what you think about that Q1. But anyway, all right, let's take a look. Design the data structure that supports add new words and find if a string matches any previously added string. Okay. I mean, especially given what we did yesterday, I think what they want you to do is use a try. Yeah, let's do it. Let's use a try. Oh, wait. There's a dot. Return true if there's any string in the data structure that matches the word, or false otherwise. I missed that. Okay. Let's see, right? That kind of mucks things up a little bit, because how would you use a try with a sort of a wild card, right? Without, you know, being really without being very exponential about it, say, right? I think for these things, there's always a consideration about what to optimize for. And what I mean by that is that, you know, well, in this particular one, there's only two functions, right? Do you want to optimize for the search, or do you want to optimize for the add? I would such. I think the only at most 3 dots. Actually, that's a very subtle thing. So then maybe you can. Excuse me. How would that mess with the complexity? I mean, I guess that changes the complexity a little bit in that now, I mean, you could do a brute force on each of the 3 dots, and then now it's just 25 to the 6 times 25 or something like that. What is that? 25 to the third is 15,000 times 25. I guess that'll be fast enough. 390,000. I just used the calculator real quick. It's annoying but possible. So let's do it that way then. I actually didn't see this, so that's a pretty big thing to kind of just hide in there. But yeah, but I was gonna say that yeah, you have to optimize for adding or searching, and it's always a little bit tricky what you really want, and also it's still a little bit tricky because for each search it does, as I said, 25 to the third times. I guess 26 to the third, right? Why did I say 25? I think I got confused by this 25 here. But 26 to the third times like 22 or something like that, right? It's going to be scary. In terms of running time, I always think about yeah, I don't know. But I guess what I'm going to do is just, you know, create a try, and then we'll see how the complex, or not the complexity. I know the complexity, but whether it's going to be fast enough. And for this, I'm also going to be a little bit lazy, in that, you know, yesterday. It wasn't yesterday. Was it 2 days ago then? Okay. For 2 days ago, we have a try class, so let's just copy and paste this. If you want to check out that video, well, I mean, you should check out that video. It's from 2 days ago. What was it? Days, is that 17? Yeah, 17. So yeah, so I'm gonna copy and paste. Ooh, whoops, I think I closed the wrong window. So I copy and paste the try class in the beginning. We may make some changes, but you know, but for now, let's do this, right? Try, yep. Add words. So insert, right? And then search is the one that's a little bit different. And we can just return self dot try dot search of word, but of course you have to make some modification here. I mean, this is going to be correct, obviously, if there are no dots. So now we have to figure out a helper for dots, right? So you can do this in a number of ways. I'm going to do this recursively. We'll see if that actually haunts me later. Let's just call it search helper, self word index, maybe something like that, right? And then basically, I'm trying to think whether I want to rewrite this or not in a way, right? But basically, whatever, return search helper self.search helper word 0, and then basically now, oh, and the current node, I guess I have to do current node, and here it's self.root, I suppose, right? I'm not deleting this yet, just in case I need it for whatever reason. But then now basically, so C is equal to word sub index, right? And we can do something like if index is equal to length of word, and then we return current is n. Otherwise, we look at the current character, and let's not take care. Let's ignore dots for now. And basically, what we would return is self dot search helper. Yeah, maybe something like if C is in current dot edges, then we return this. And current dot edges of C, word index plus 1, right? I think this one's okay. But if it's not, then we have to if C is not period, then we return false, right? Because that just means that we don't match, so we return false. Otherwise, we want to do a brute force on each character, which is from A to Z. And basically, if X with char of X plus order of A. Okay, so maybe current, this is the new character that we're parsing. If now is in current dot edges and self dot search helper current dot edges of now word index plus 1, then we return true. And that's pretty much it, I think. Now we can remove this. We don't, I mean, this, I'll just remove it anyway for less confusion. This looks good for this one, but the input doesn't look that scary, so we'll just give it submit and YOLO and see if we missed an edge case or time limited or whatever. Hopefully not, but it's hard to do the math on this. Or at least very precisely, right? 1080, 13 seconds, a little slow. How did I do last time? Oh, that's smart. But that's like but that's like such a guess of an optimization. I wouldn't go about it. Did a try here, and that took. That was much faster for some reason. Huh. Oh, this makes way more sense. I see what I did there. So I did do an optimization that I did not do, which is that instead of for X in this, I do for X in current dot edges dot keys. So then now, by definition, we don't need this because well, you know, by definition it's in it, right? So let's try it again and see. I actually forgot about the optimization. I mean, I could have made the optimization if I was forced to, but I guess I wasn't forced to, which is good. But yeah, and this is much faster. It went from 13 seconds or 14 seconds to 9 seconds, but still, notice really not super fast. So I think they just added a lot more cases in the 2 or 3 years since then. Because the code looks mostly the same, actually, right? Yeah, I mean, I don't know. So what is the complexity, right? As I mentioned, this is going to be, I mean, the insert, you know, we did it in the other video. This is going to be linear in the size of the input, which is the word, right? Because it just look at one character each and it creates a node if necessary. The search is the more interesting part. And there are a couple of ways that you can think about it, a couple of dimensions that you need to kind of consider, right? So one is the length of the word that we're searching for. So let's just say L is the length of the word. And then the other is, I mean, and we kind of have some optimization with respect to this thing that we kind of did. But let's just say D is equal to number of dots, right? And A is equal to the size of the alphabet. Then this is going to take, roughly speaking, A to the D times L, right? It's not quite, it's an upper bound for sure. You can maybe even say L minus A or L minus D or something like that, but that's, I mean, and you know, it's still going to be roughly the same. So yeah. And then in space, there is O of L for stack space, right? That is the way that we did it. I guess the way the one is faster because it's not pure recursion as well. Because I think I do a for loop. Oh wait, no, I don't. I lied. But yeah, that's all I have for this one. Like I said in the other video when we first did it, tries come up all the time on Leetcode, so definitely be familiar with it. Play around with it, really understand it. I think, yeah, and in this case, it is very tricky. But basically, we're doing the exhaustive search is what we're doing. I don't know that I explained it that much on this one. But basically, if it is in the current edge, then we just go to the next index. Otherwise, if it is a dot, which is here, then we brute force matching any one character and then try to see if any of them return true. So that's basically the idea. Yeah. That's all I have for this one. I'm going to prepare for the contest by taking a nap. But yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.